Hello, today we're presenting to you everything we know about database management system. But before we going to know what it is and how it works, we have to know a little bit about the history behind it. Since the ancient time, humans began to store information for a very long time through multiple types of ways, such as writing on paper, or writing on trees, or even writing on stone. Elaborate database systems were developed by the government office, libraries, hospitals, and business organizations, and some of the basic principles of this system are still being used today. Thanks to the advancement of computer science, computerized database started in the 1960s when the use of computers became a more cost-effective option for private organizations. There were two popular data models in this decade, a network model called Codacil and a hierarchical model called IMS. One database system that proven to be a commercial success was the Zebra system that was used by IBM to help American Airlines manage its reservation data. In 1970, Edgar Frank Codd published an important paper to propose the use of a relational database model, and his idea changed the way people talk about database. In his model, the database schema or logical organization is disconnected from physical information storage, and this became the standard principle for database systems. Two major relational database system prototypes were created between the years 1974 and 1977, and they were the Ingres, which was developed by UBC, and System R created at IBM St. Joseph's. Ingres used a query language known as QUEL, and it led to the creation of systems such as Ingres Code, OnePace, and Pretendly. On the other hand, System R used the SQL query language, and it contributed to the development of DB2, RBase, and Oracle. It was also in this decade that relational database management system became a recognized term. In 1976, a new database model called Entity Relationship was proposed by Peter Chen. This model made it possible for designers to focus on data application instead of logical table structure. Structured Query Language or SQL became a standard query language in the 1980s. Relational database system became a commercial success as the rapid increase in computer sales pushed the database market, and this caused a major decline in the popularity of network and hierarchical database model. DB2 became the flagship database product for IBM, and the introduction of IBM BC resulted in the establishment of many new database companies and the development of products such as Paradox, RB5000, and Wacom SQL. Early in 1990s, after a database industry shakeout, most of the surviving companies sold complex database products at high price. Around this time, new client tools for application development were released, and these include the Oracle Developer, Power Builder, and others. A number of tools for personal productivity such as ODBC and Microsoft Excel Access were also developed. Prototypes for object database management systems were also created around this period. In the mid of 1990s, the advent of the Internet led to exponential growth of the database industry. Average desktop users began to use client-server database systems to access computer systems that contain legacy data. Increased investment in online businesses in the late of 1990s resulted in a rise in demand for Internet database connectors, such as FrontPage, Active Server Page, Java Servlet, and Oracle Developer 2000. The use of CGI, MySQL, Apache, and other systems brought open-source solutions to the Internet. With the increased use of point-of-sale technology, online transaction processing, and online analytic processing began to come of age. Although the internet industry experienced a decline in the early of 2000, data applications continued to grow. New interactive applications were developed for PDAs, point-of-sale transaction, and consolidation of vendors. Presently, the three leading database companies in the Western world are Microsoft, IBM, and Oracle. Today, databases are everywhere and are used to enhance our day-to-day life, from personal cloud storage to predicting the weather. Many of the services we utilize today are possible due to databases. Presently, there are many new players in the non-relational database space offering specific solutions. Some of the current relational databases include giants such as Oracle, MySQL, and DB2. We're also seeing new trends emerging that focus on making powerful technology accessible to everyone. Now that we know a brief history about database, we're moving on to what it is and how it works.
Hello everyone. Now we're gonna move on to the next section of the database, which is the database management system. So, what is a database management system? A database management system basically is a database plus a management system. A database is a collection of data, and a management system is a set of programs to store and retrieve those data. So based on this, we can define database management system as a collection of interrelated data and a set of programs to store and access those data in an easy and effective manner. Database system are basically developed by large amount of data. When dealing with huge amount of data, there are two things that require optimization: is a storage of data and a retrieval of data. The purpose of a database system is to manage the data. So we can consider like a university that keep the data of students, teachers, courses, and books, etc. To manage those data, we need to store this data somewhere. Where we can add new data or delete unused data or update the data and retrieve the data. To perform this operation on data, we need a database management system that allows us to store the data in such a way that this operation can be performed on the data efficiency. There are four components to a database management system. First is the user. The user can be of many kinds, such as database administrator, the system developer, or the database user themselves. Next up is the database application, which is the application that use the information inside of the database, which is the database. And next is the database management system, is a software that allows user to create and manipulate the database asset. And last is the database itself is a collection of the logical data as a single unit. A database management system allows the user to perform the following tasks. First off is data definition. Helps in creating, modifying, and removing a definition that defines the organization of data in database. Second is data updation. Help in inserting, modifying, and deleting of the data in the database. Third is the data retrieval. Helps in retrieving of data from the database, which can be used by application of such. And last up is user administration. Helps in registering, monitoring user, enforcing data security, monitoring performance, maintaining data integrity, dealing with concurrency control, and recovering information corrupted by unexpected failure. Last up, we have the advantage of using a database management system. Database management system has many benefits. These are data independence, which is an application program should be as free or independent as possible from details of data representation and storage. A database management system can supply an abstract view of the data for insulating application code from such facts. Second is efficient data access. A database management system utilizes a mixture of sophisticated concepts and techniques for storing and retrieving data competently. This feature becomes important in cases where the data is stored on external storage device. Third is data integrity and security. If a data is accessed through the database management system, the database management system itself can enforce integrity constraints on the data and increase the security. Last up is the data administration. When several users share the data, integrating the administration of data can offer significant improvement. Experienced professors understand the nature of the data being managed and can be responsible for organizing the data representation to reduce redundancy and make the data to retrieve efficiently. That is all for the database management system. Thank you everyone for listening, and we will move on to the next section.
Depending on the user's requirement, there are following types of databases available in the market. The first one is relational databases. Items in a relational database are organized as a set of tables with columns and rows, and it relates to each other. The second one is object-oriented databases. Information in an object-oriented database is represented in the form of objects, as in object-oriented programming. The third one is distributed databases. A distributed database consists of two or more files located in different sites. The database may be stored on multiple computers located in the same physical location or scattered over different networks. Data warehouse is a data central repository. A data warehouse is a type of database specifically designed for fast query and analysis. NoSQL databases or non-relational database allow unstructured and semi-structured data to be stored and manipulated. Graph databases. A graph database stores data in terms of entities and the relationship between entities. OLTP databases. An OLTP database is a speedy analytic database designed for large number of transactions performed by multiple users. This type of data is known for its high performance, faster accessibility, and reliable, consistent data. And some of latest databases: open source databases, cloud databases, multimodal database, document or JSON database. JSON means JavaScript Object Notation, and self-driving databases.
This is last part of our group presentation, and it talk about cloud computing, and its content includes the definition of cloud computing, model deployment, advantage or disadvantage, benefits, and application. So what is cloud computing? Cloud computing is a computing model that uses computer technology and is based on the internet, and it is on provided as service that allow user to access the service from a certain provider in the cloud. And cloud computing is the most popular database used for storage, such as Google, Android, or something like that. There are two types cloud computing. These are public, private, hybrid, and community cloud. First, first of all, public cloud. Public cloud is not limited to user, allow people to use and share information. The good side of public cloud are serve many users, unlimited time to space, low investment cost, can be scaled according to user needs. The bad sides are unsafe and difficult to control data. Secondly, private cloud. Private cloud is often used in companies to ensure data security and protection by firewalls and directly managed. The good side of public cloud are more flexibility in using and managing data and better information security. The bad sides are difficult to deploy technology. The cost a lot of cost money to build and maintain the system. Finally, only serve the business. Next to that is hybrid cloud. Hybrid cloud is a combination of public cloud and private cloud. It uses the strength and quickness of two models and will usually be created by company. The good side of hybrid cloud is ensuring data security, use many services without restriction. The bad sides are difficult to deploy and manage the system. It costs a lot up to build the system. Finally is community cloud. Community cloud like the same public cloud is also allow users to access and share information, but those users must be in the same company and organizations or business. The good side are organization, business, individuals operating in this area can easily share data and information to serve their own work, ensure privacy, security, and better policy compliance. The best side are difficulty in management and administration, cost a lot to build and develop. Next that is benefits of cloud computing. There are four benefits. First, cost saving to convenient help user can quickly access and use resources over the internet without complicated settings. 3. Safe and continuous ensure higher safety, avoid data loss due to hard drive failure. In addition, the provider will regularly check the backup of the data and perform security measures to better protect data. And finally is fast deployment. The last part of my presentation is application of cloud computing. There are 6 applications: 1. Cloud database, 2. Testing, developing web and applications, 3. Big data analysis, 4. Data storage for the web, 5. Store and share data, and finally enterprise management application. Thank you for listening to my presentation and goodbye.